Welcome to second session of DSP. In this session, we will be discussing about signal operations. In the last session, that means in the first session, we discussed about convolution, and we saw that convolution operation involves multiple signal operations. So in this session, we'll discuss about two of them in detail. So this is the agenda for this presentation, and as you can see here, we'll be discussing about two important signal operations which are carried out with respect to time variable. So time variable is an independent variable. The first operation is time shifting. Time shifting operation replaces n by n minus k if you have a signal x of n. And similarly, you have time reversal, which replaces n by minus n. So we want to know more about these two operations. And also, there is a rule called precedence rule that we'll be discussing. So when you have to perform more than one operation, and if it involves time shifting operation, and what is the order in which these operations to be performed. So that is called as precedence rule. So we will be discussing about this, as well as the logic behind these two operations, time shifting and time reversal. In this slide, you can see that there is a time shifting operation that is described. You have a original signal, which is x of n, which is a discrete time signal with 6 samples starting at n equal to minus 2 and up to n equal to 3. And these are all the different amplitudes. At n equal to minus 2, it has an amplitude 3, etc. So this is the signal x of n. Now, what we want to understand is what happens when you perform a time shifting operation on this original signal. So we want x of n minus 2. So x of n minus 2 means we shift the signal x of n to the right by 2 samples or 2 units, you can say. So this is what you're going to get. So in x of n, the samples start at n equal to minus 2, goes up to n equal to 3, and when you shift it by 2 samples, and you get samples starting at n equal to 0 till 5. So since right shift is also called as delay, because the sample which appears at n equal to minus 2, now in a new signal it appears after 2 samples. So that means there is a delay of 2 samples or 2 units, we can say. So this is called as right shift operation or delay operation. But we want to understand the logic behind this, why time, for example, why x of n minus 2 shifts the signal to the right. So this is one thing we want to understand. We want to understand the logic behind this. We'll move on to the second one. So that is called time, another kind of a time shifting operation called as a left shift or advance operation. If you have a signal x of n, and if you want to obtain x of n plus 3, so in that case you will have to shift this waveform to the left by 3 samples. It means that in the original signal, if samples start at n equal to minus 2, so now it will start little early, 3 samples early, that means at n equal to minus 5. But you can see here there is none of the amplitudes are modified. We are not performing any operation on the y-axis variable, that is amplitude. Okay, so operation is performed only on the x-axis, that is time variable or independent variable. So this type of time shifting operation is called as advance operation, which is also called as a left shift operation. So where you replace n by n plus 3, or if I have to generalize it, n is replaced by n minus k, where k is negative in this case. So here also we want to understand why it is left shift. So to do that, to understand the logic behind this, what we do is, if you look at this, in both the cases, I'll just go back to right shift. As you can see here, this is the origin. For a original signal, here is the origin, n equal to 0, and you have a sample with amplitude 4. What exactly you are doing is, you are just shifting your origin, to the left. That means when your entire signal goes to the right, ultimately you are moving your number line. Number line is this x-axis, or you are shifting your time origin to the left by 2 samples. You can see that at the origin here you have this sample, but in x of n minus 2 at the origin you have a very first sample, that is this particular sample. So ultimately the time axis is more in the left hand side, towards left hand side by 2 samples. So you are shifting the origin n equal to 0 to the left. So that way you can think of. And similarly for this, in this case, if you look at the samples, if you look at the amplitudes, the entire signal is shifted to the left. But if you talk about the origin here, you are moving the origin towards the right by 3 samples. That means at origin you have amplitude 4 right now. So instead of that, in the new signal you will have this particular sample at the origin. So this is one way we can remember this. That means we are performing operation on the time axis. That means we are shifting the time axis either to the left or to the right, or maybe the signal will be moved. That means that samples will be moved in the other direction. So this is what this is one way we can remember this. The second way, we can use a simple math to verify whether the graphical representation is correct or not. For example, from x of n, you have obtained x of n plus 3 by left shift, but we want to verify whether it is correct. For that, what we do is, let's say we already know about x of n, we know the amplitude at each time instant, which are given here. X of minus 2 is 3. This is from the original signal. In order to obtain the samples of this signal, x of n minus 2, or let us say x of n plus 3, what we do is we equate it to a new signal called y of n, and after that we substitute for n equal to 0, n equal to 1, even for negative values. You can keep substituting it in this equation, and let's take n equal to 0. So y of 0, we want a sample at n equal to 0 for x of n minus 2. So we substitute n equal to 0 here, that is x of minus 2, and x of minus 2 is already known, that is 3. So this way we can compute all the samples of the new signal, and we can plot it, and we can compare it with the graphical representation that we have seen earlier. So same thing can be done for x of n plus 3 also. So this way we can verify using a simple math, as well as we should also remember that since the operation is performed on independent variable, that is n or time, so you will be shifting the time axis to the left or to the right. When you say the signal is shifted to the right, that means if you want x of n minus 2, instead of that you can assume that the time axis itself or the origin itself is shifted to the left by 2 samples. So this way we can remember this. So this is the quick review on these 2 operations, signal operations, which are carried out on independent variable. So in the next session we will we'll discuss about other operations which are carried out on a dependent variable. So now let us move on to the next operation, which is called as a time reversal operation. which is also called as a folding operation. You have the original signal here, and as you can see that you are mathematically, if you are describing this, n will be replaced by minus n in x of n. So if original signal is x of n, this is x of minus n. And you can see that the sample at n equal to minus 2, now that will appear at n equal to plus 2. And similarly, sample at n equal to 3 will appear at n equal to minus 3. So this is called as a time reversal or a folding, or you also call it as a reflection. Now, so that time reversal is easy to understand when compared to time shifting operation. What if you have to perform two operations on the original signal? Let's assume that x of n is given and you need x of minus n minus 2. As you can see here, there is a minus n, which indicates time reversal operation, and n minus 2 indicates that there is a shifting. So that means in order to obtain this signal, we need to perform two operations: time reversal, time shifting. Now, which one to be performed first? That is very important. You cannot reverse the order. We can't perform both the operations at the same time. So you need to, have a order here, order of the preference. So here comes the precedence rule, which says that first you need to perform time shift always, and after time shifting you need to perform maybe time reversal or time scaling. Time scaling operation will not be discussed here. We'll discuss it separately. After performing time shifting, you can perform whichever you need. For example, time reversal, or let's say time scaling, etc. So let's assume that we need x of minus n minus 2. So first you perform time shifting operations. That will give you x of n minus 2. We are already familiar about this. Now once you get the time shifted signal, that means time shifting, what it does is it replaces n by n minus 2. So this way we can think. And once you get the time shifted signal, now you perform time reversal on this signal, x of n minus 2. As you know that time reversal will replace n by minus n. So there is an n here, and that will be replaced by minus n, and this signal will be folded. That means instead of right side here, you get the samples on the left side. But sample at n equal to 0 will remain as it is. It doesn't change, because minus 0 plus 0 will be same. So this will be the new signal, x of minus n minus 2. So first we perform time shifting, followed by time reversal. So this is the correct order. Now what happens if you reverse this order? Let's say I perform time reversal first. If you perform time reversal first, you will get x of minus n, because you know that time reversal will replace n by minus n. Then you perform time shifting. So time shifting will replace n by n minus 2. So n, that will be replaced by n minus 2. So you will be getting x of minus n plus 2, which is different from the signal which we wanted. Okay, so this is not a correct order. So we need to follow precedence rule when you have to perform two operations, and time shifting is one of the operations. So this is about part 2. In session 2 we discussed about signal operations which are performed on time variable. In the next session we will also see other examples. What happens if these signal operations are performed on a two-dimensional function. For example, if you take an image, or maybe a one-dimensional function like if it's audio signal, what happens? So we'll discuss more about the signal operations in the coming sessions. So thank you.